SpaceX's Starship, heralded as the most powerful rocket ever constructed, is poised for its 10th test flight on Sunday, August 24, 2025, at 6:30 p.m. from Starbase in South Texas. This monumental vehicle, standing 400 feet tall and generating 16.7 million pounds of thrust, aims to revolutionize space travel by enabling missions to the Moon, Mars, and beyond. However, despite its ambitious goals, the Starship program has encountered significant challenges, raising concerns among experts about its viability and safety. The Starship system comprises two main components: the Super Heavy booster and the Starship spacecraft. The Super Heavy booster, equipped with 33 Raptor engines, provides the initial thrust needed to escape Earth's gravity. Once the booster expends its fuel, it is designed to separate from the Starship spacecraft, which then continues its journey to orbit or its designated destination. This design emphasizes reusability, a core principle of SpaceX's approach to reducing space travel costs. Despite the innovative design, the Starship program has faced a series of setbacks. The last 3 test flights ended in explosions, with the most recent in June 2025 attributed to propellant mixing in the payload bay. Earlier failures were linked to malfunctions in the main fuel tank and issues with the pressurization system. These repeated failures have prompted the Federal Aviation Administration (FAA) to ground the program temporarily until identified issues were addressed. The FAA has since approved the next launch attempt, contingent on the implementation of corrective measures. Experts expressed concern over the rapid pace of development and the frequency of failures. Jonathan McDowell, an astrophysicist at the Center for Astrophysics, Harvard and Smithsonian, notes that developing a vehicle of Starship's size and complexity is inherently challenging. He emphasizes that while SpaceX is making progress, the risk of fundamental engineering issues remains a significant concern. The use of cryogenic fuels, such as liquid methane and liquid oxygen, introduces additional complexities due to their extremely low temperatures and the challenges associated with thermal cycling. These factors can lead to structural stresses and potential failures if not meticulously managed. The stakes are particularly high given the ambitious missions planned for Starship. NASA's Artemis 3 mission, scheduled for 2027, intends to use Starship to land astronauts on the Moon's south pole. Additionally, SpaceX envisions Starship as a vehicle for interplanetary missions, including potential crewed missions to Mars. The success of these missions hinges on the reliability and reusability of the Starship system, making each test flight a critical step toward achieving these goals. In response to previous failures, SpaceX has implemented design modifications and conducted rigorous testing. For instance, the company identified issues with the pressurization system diffuser and the Super Heavy booster's fuel transfer tube, leading to loss of control and crash landings in earlier flights. These insights have informed design changes aimed at enhancing the system's robustness and performance. As the 10th test flight approaches, the space community watches closely. While there is optimism about the potential of Starship to transform space travel, the recurring technical challenges underscore the complexities involved in developing such an advanced system. The outcome of this upcoming test flight could significantly influence the trajectory of SpaceX's ambitious plans and the future of space exploration. In conclusion, while Starship represents a monumental leap forward in rocket technology, its development is fraught with challenges. The upcoming test flight serves as a pivotal moment for SpaceX to demonstrate the viability and safety of its design. The lessons learned from this test will be crucial in determining whether Starship can fulfill its promise of revolutionizing space travel or if fundamental engineering hurdles will impede its progress.